Alright, I'm dropping it in the chat. So this is the third most asked Google question this month.
Okay, let me know when you're ready to. Oh,
Yeah,
I
you
should
can
share
go
the
ahead and
screen
share your
first.
screen. Yeah.
Yeah. All right, start the timer. Partition string. Uh, Given a string S, partition it into unique segments according to the following procedure. Start building a segment beginning at index 0. Continue extending the current segment character by character until the current segment has not been seen before. Once the segment is unique, add it to your list of segments, mark it as seen, and begin a new segment from the next index. Repeat until you reach the end of S. Return an array of string segments where segment set I is an ith segment created. So example A, B, B, C, 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 D. Output A, B, C, B, C, 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 D. Okay. Okay. So let's look at the explanation. Index 0. We get A. After segment, after adding, so we added to our seed segments. Current segment seen before? No. New segment. Updated scene segments. Next iteration, B. We haven't seen it before. Added to scene segments. Next character B, we have seen it before. New segment B. We added to, we don't change our scene segments. Next iteration, BC. Or I guess segment after adding. C is not in scene segments, no. So we, oh, I see how this works. And then add BC to the scene segments. Next iteration C, we haven't seen before, just a single C. So we add to scene segments. Um, and then fifth iteration C, we haven't seen it before, so don't add it to the scene segments. Sixth CC, we haven't seen it before, add it to scene segments. Okay, 7D, have not seen it before, added to scene segments. Okay, I understand. And then AAAA, so I guess the edge case here would be at the last index. We have seen it before, and no characters left, so we don't do anything with it. Okay, so first let's go over the edge cases. Um, let's see. So how, first let's think of the input actually. The constraints of the string that's given to us, which is going to be it can either have a length of 1 to 10 to the fifth power and only contains lowercase English characters or letters. Okay, so some edge cases here. Trying to think of some. Um, I guess the only edge case I can think of for now is if I reach the end, and the current segment, sorry, this is kind of in the way. And the um, current segment is in the scene segments. Let's get rid of it. Okay, I see, I see. Yeah, I don't think there are too many edge cases for this problem, or not that I can see from the get-go. So now I'll start thinking of the solution. Um, so to keep track of the scene segments, I'm going to use a set uh, of scene segments. And then at the end, I'm going to convert it to a list. And which is converting it to a list is going to take me O of n time. Um, and so I have my list or my set of scene segments. And I'm going to have to iterate through this list and go look at every single character. So I think the best and with the best like most optimal solution would be O of n. I think this is the best I can make it. Um, so now moving on to the actual solution, I have to I'm going to iterate through each character in S, and I'm going to have I'm going to keep a string called cur segment, which is going to be the current segment. And with each iteration, I'm going to add the current character to cur segment, and then check if this is in my scene segments. So now we have two cases here. If it's in scene segments, then, or if it's not in scene segments, if not in scene, then I'm going to add to my scene segments. If this has been seen, then I'm going to I'm going to um add on to my current character or current segment. Oh, sorry. Um, Before all this, I'm going to add character to current segment. And if it's not in scene, then add to scene. If it has been seen, then just don't do anything. Then just continue. All right, so now this is my solution. Time to code it up. Um, time to code it up. So first, I'm going to create my set. Let's call it scene segments, which is going to be a set. And I'm going to uh create another variable called cur segment. It's going to be an empty string for now. Um, and then I'm going to iterate through each character in my string. And how should I do it? I don't think I need an index here, so I will just do for character in S. Um, for character in S, I'm going to first append it to my current segment equals character. Um, and then I'm going to check is if current segment is in scene segments. Now, if it's not in scene segments, then I'm going to add it to my scene segments. Add it to my current segments, or add it to scene segments. And I think that's it. And after this for loop completes, just return list version of scene segments, which should give me all of the scene segments. It should, it should. Right. Okay, I think this is my solution. Um, Now before I run it, I'm just going to run it through one more time, just in my head, just by looking at it, trying to see if there are any cases that I have possibly missed. So set current segment for character in S, add it to current segment. Oh, there's one thing that did mess up. Um, Once I add it to my set, I'm going to reset current segment to be an empty string again. Yeah. All right. So now I think it should work. And I'm going to press run to test it now. Fuck. Why this is outputting a D? I Oh. Oh my goodness. Now I see a major flaw. The ordering matters because in a set, the stuff you add to, the characters you add to it are not ordered at all. So knowing this, I will have to redo, um, well, not redo, but I'm going to increase my space complexity and have another, let's see, another output array. I'm going to create it. I'm going to just call it output, which is just going to be an array. And when I add to my scene segments, I'm also going to append it in my output array, cur segment. Um, and then all I'm going to do is return output instead. And it's still good to use scene segments because it has an O1 lookup time, so I'll be keeping that. Run it now, should be good. Boom. Submit it, should be good. Boom.
All right.
All right.
Um, I do have some thoughts.
Okay.
Um, I think
And
that
wait,
yeah.
before I should have talked about this before submitting my solution, but the time complexity of this is O of n, and the space complexity would be O of n as well, because I'm keeping track of scene segments and I have outputs as well.
Okay.
Yeah.
Um, so one of the major things is that you rush through the understanding of the problem and you kind of
Hmm.
missed like a fundamental piece, which was that the ordering mattered.
Yeah, but I caught
So
it before I ran my code.
you did, but you ran the test cases first before you
No,
caught that.
I did. Oh, I did. You're right.
Yeah.
Fuck.
So I feel like a problem that you have is that you don't go through manual test cases before you spam run, which I don't think is good.
Like,
Because if you're I mean most of these interviews aren't going to have an IDE, so if you're just submitting, you're not going to know if these test cases are running or not. So I would have liked you to manually go through because I mean like look how much time we have left. We have
no,
23 minutes left. You should have put it on the whiteboard and manually gone through the test case, and then you would have figured out that your code is broken, but you just like spammed run, which
that's
is,
true.
yeah,
But
which is not very good.
counter argument, it never said the ordering. I don't know. Yeah, you're right though. It never said
It
ordering.
does, it does say the ordering matters.
Wait, where?
It's pretty clear in the output. And also, like, you could have asked me.
I could have asked you.
You
Yeah.
just assumed that it didn't matter.
Fuck.
So I feel like
Right, you're right.
I don't
You're
know.
right.
I don't know why you care so much about like getting it in so quick because it doesn't matter like how long it takes. If anything, like you're gonna fuck yourself by not fully understanding what's required of you and then also just spamming until you get it right.
No, you're right. You're right. You're right. You're right. You're right. All right. So what's the final score? Show me the final score.
I'm gonna have to add it up. Well, we can stop the recording here.
We can. I don't mind recording like the rubric as well. It's not like, or should we stop it?
Yeah.
All right.